Hey guys, we are going to learn how to balance equations today. You should have already downloaded your balancing act worksheet into your Notability while you are watching this, and we will fill it out together. Okay, so first let's read the top together. It says, atoms are not created or destroyed during a chemical reaction. Scientists know that there must be the same number of atoms on each side of the equation. To balance the chemical equation, you must add coefficients in front of the chemical formulas in the equation. You cannot add or change subscripts. Okay, so how does that work? If you notice right over here, this is a chemical equation that we are going to try to balance. There are 4 steps. You can see them over to the side. Step 1 is to determine the number of atoms for each element. Step 2 is to pick an element that is not equal on both sides of the equation. And step 3 is to add a coefficient in front of the formula with that element and adjust your counts. And then finally, step 4, continue adding coefficients to get the same number of atoms of each element on each side. Okay, so we are going to work on this problem, the one that is magnesium plus oxygen. We are going to do that one on the next slide. Now, as you see here, all I've done is just blown up the equation so that way you can see it more closely. It still says magnesium plus oxygen equals magnesium oxide, and we are going to balance that equation. So step 1, what we have to do is we have to count how many atoms are on each side of the equation. For example, you notice here that the oxygen has a 2. That means that there are 2 atoms of oxygen. We can record that just like that. Now, magnesium does not have a subscript, so we just assume that there's only 1. Now we move over to the product side. This side is considered the product side. And we notice that there aren't any subscripts on the magnesium or the oxygen, so we just assume both are 1. Now, as you notice, the oxygens are not equal. On the reactive side, it's 2, and on the product side, it's 1. So we need to change that to where they are the same. First thing that I always do is I recognize that I need to make this oxygen over here equal 2. So I think to myself, what can I multiply by to equal 2? Well, seems pretty easy. Just multiply it by 2. And when I do that, I have to carry that number to put it in the coefficient place, which just means before. So I put the 2 in this box. But now, due to the distributive property, if you remember, you have to always distribute. So I distribute this 2 to the Mg, which takes that from a 1 to a 2. And then I distribute it also to the oxygen, which, as we know, it was to equal 2. And it does. It does equal 2. Now, I'm not even on the other side. As you notice, the magnesium on the product side is 2, whereas on the reactive side, it's only 1. So I think to myself again, what can I multiply by to equal 2? And of course, it's easy, it's 2. So I have to take the 2 and I have to put it in front of the magnesium because it's the magnesium I want to change to equal 2. So now, as you notice, magnesium on the reactive side now equals 2. The oxygen equals 2. And then on the product side, the magnesium also equals 2 and the oxygen 2. So because the magnesiums are equal and the oxygens are equal, my equation is considered balanced. You can always check by multiplying over here. If I were to take the 2 times the 1, which is what we consider when there is no subscript, we get 2. And of course there is a 2 on the oxygen, 2 times the 1 subscript is 2, and 2 times the 1 subscript for the oxygen over there is, of course, 2. So now we have our first balanced equation. Alright, let's do this next one together. If you notice, this one has calcium, oxygen, and then calcium oxide. Let's start by doing step 1, which says that we have to determine how many atoms are on each side initially. So, I look here and I notice that there's no subscript on the calcium, so I just say it's 1. The oxygen, there is a subscript, and it happens to be 2. On the product side, both calcium and oxygen do not have a subscript, so they are both 1. Immediately I notice that the oxygens are not equal, so I have to think to myself, what can I do to change this 1 to 2? Well, it seems pretty easy. I just multiply 1 times 2. And when I do that, if you remember, I have to carry that number to the product side in the coefficients place. Now that changed not only the oxygen is now 2 times the 1, 2, but so is the calcium. So we have to change the calcium to 2 as well. Now, if you notice, we've now unbalanced the calcium. The calcium on the reaction side equals 1, but on the product side it equals 2. So we have to think to ourselves, what can we multiply 1 by to equal 2? Well, of course, it's 2. And we take that number and we put it in the coefficient spot over by the calcium. Now, 2 times the 1 subscript is 2, and oxygen still has the 2 for its subscript. So now we see that the calcium is equal at 2, and the oxygens are equal also at 2. So we have our second balanced equation. Next, I'm going to take a look at the equation that's with the nitrogen. It's nitrogen plus hydrogen. This is actually ammonia. It doesn't sound like nitrohydride or anything like that. It's something different. But anyhow, as we notice, first we have to balance the equation by counting the subscripts. So for nitrogen, it is 2 on this side. For hydrogen, it is also 2. For nitrogen on the product side, it is 1 because there is no subscript, but hydrogen happens to be 3. And if you notice, we're really far off. We have, on the reactive side, 2 for hydrogen and 3 for hydrogen. That looks like it's going to be pretty hard, because what we have to think is, what would be a least common multiple? Now, how I find the least common multiple is I just multiply the numbers by each other, 2 and 3 respectively. So what that looks like is me taking the 3, multiplying it by 2 to equal 6. And then on the reactive side, 2 multiplied by 3, that equals 6. So there I have 6 balanced. Now what does that look like? How can I take and make my equation balanced knowing those numbers? Well, as I said, it's the number that you multiply by, as I'm highlighting here. Oops. It's the numbers that you multiply by, that you record in the coefficient spot. So, for hydrogen, it's going to be 3. So for hydrogen, it's going to be 3. But then, for the hydrogen over here, it's going to be 2. I just record it 2. Okay, but now I've thrown off my equation a little bit. I have to refigure. So I have, if you notice on this side, I have to distribute. I have to distribute this 2 to the n also, which changes it to 2. And then, of course, I've already distributed it to the h because that's how I got the 6. Now over here, I can leave my nitrogen at 2 because, as you notice, now the nitrogens are equal at 2. And the hydrogens, of course, as we figured, are equal as 6. Now we have a balanced equation. Now the last two problems could be considered kind of difficult. I'm going to start with the copper equation. This is copper and oxygen and carbon, and then copper, carbon, and oxygen. And if you notice, this together is actually carbon dioxide. So, first thing we have to do is we have to count how many atoms are in each part of the equation. So if you notice, the Cu has a 2, so we'll record 2. The oxygen does not have any, so we just put 1. And then the carbon also does not have a subscript, so it is 1. Now over on the product side, the copper does not have a subscript, so we just record 1. The oxygen does, it happens to be 2, and the carbon, if you notice, right next to the carbon there is no subscript, so it is 1. Now we are really scattered. We notice first we have the coppers that are uneven, but we also have the oxygens that are uneven. I don't think it really matters which one we start with, but I think I'd like to take a look at the coppers. So, what we have to do is we have to think what times what would equal 2, because again, we're trying to get the coppers to both equal 2. Well, of course, it's 2. So I take that 2 and I put it in the subscript on the product side. And that just changes the copper to 2. Okay, so now my coppers are equal, but my oxygens still are not equal. So what about if I take and I think to myself, what can I multiply over here to equal 2? Well, again, it's 2. So then I record that in the oxygen coefficient place, which is way over here with the copper. Okay, now as you notice, my oxygen is now 2 times 1, which of course is the 2, which is great, because that's what I needed it to equal. But now I have to take 2 times 2, which changes my copper, because I've changed that number. So now my copper is no longer 2, but it's 4. Now I'm uneven again. So if you notice, on my reactive side I'm 4 for copper, but I'm only 2 on my product side. So I have to go again. Now, this is pretty easy because if you notice, the copper is 2 and I need it to be 4. That's going to be a real easy fix because all I need to do is just change that 2 to a 4. And there we have it. I have 2 times 2 for my copper to equal 4. Perfect. 2 times the 1 for my oxygen to equal 2. That's perfect. And then again, my carbon just stays at 1. Over here, I have 4 times my 1 for copper, which equals 4, which is perfect because I needed the coppers to equal each other, and now they do. They equal at 4. And now, again, I didn't put a coefficient here, so my oxygen stays at 2, and my carbon stays at 1. So there, I have a balanced equation.